When most people imagine the universe, they picture an endless sea of stars and galaxies spread throughout space. Telescopes show us dazzling images of spiral galaxies, glowing nebulae, and clusters containing thousands of galaxies bound together by gravity. At first glance, it might seem as though the universe must be filled with matter everywhere we look. However, modern astronomy has revealed something far more surprising. On the largest scales, much of the universe is almost completely empty. Enormous regions exist where very few galaxies can be found. These regions are known as cosmic voids, and they are some of the largest structures in the entire universe. Some cosmic voids stretch across hundreds of millions of light years, making them far larger than individual galaxy clusters or even superclusters. To understand how these vast empty regions formed, we must look back to the earliest stages of the universe shortly after the Big Bang. In the beginning, matter was distributed almost evenly across space. However, the universe was not perfectly uniform. Tiny fluctuations in density existed even then, with some regions containing slightly more matter than others. These small differences were incredibly important because gravity gradually amplified them over billions of years. Regions with slightly more matter began pulling in additional gas and dark matter from their surroundings. Over time, these dense regions grew larger and eventually formed galaxies, clusters of galaxies, and enormous superclusters. Meanwhile, regions that began with slightly less matter gradually lost even more material as gravity pulled it toward the denser regions nearby. As matter drained away from these underdense regions, they expanded and became emptier over time. Eventually, they evolved into the enormous cosmic voids we observe today. When astronomers map the positions of galaxies across vast distances, the universe appears to have a remarkable large-scale structure. Instead of being distributed randomly, galaxies gather along enormous filaments of matter that stretch across hundreds of millions of light years. These filaments intersect at massive clusters and superclusters of galaxies. Between these filaments lie enormous bubble-like regions that contain relatively few galaxies. These are the cosmic voids. The entire structure resembles a gigantic three-dimensional network, often called the cosmic web. This web-like pattern is one of the most striking discoveries in modern cosmology. Computer simulations of the universe show that the cosmic web formed naturally as dark matter and gravity shaped the distribution of matter over billions of years. Dark matter, which makes up most of the mass in the universe, plays a crucial role in forming this structure. Invisible halos of dark matter act as gravitational scaffolding that pulls normal matter into filaments and clusters. Meanwhile, the spaces between these structures gradually become emptier, forming the enormous voids that dominate the volume of the universe. Some cosmic voids are so large that they contain almost no major galaxies at all. Within these regions, the density of matter can be far lower than the cosmic average. Because they contain so little matter, voids allow astronomers to study how the universe evolves in relatively undisturbed environments. Although cosmic voids may appear empty, they still play an important role in shaping the motion of galaxies across the universe. Galaxies located near the edges of voids tend to move away from these empty regions and toward the dense filaments and clusters that surround them. In this sense, cosmic voids behave somewhat like expanding bubbles in the large-scale structure of the universe. As matter flows toward denser regions, the voids continue to grow larger and emptier over time. This process gradually increases the contrast between dense galaxy clusters and the vast empty spaces between them. Over billions of years, This evolution has helped produce the intricate cosmic web that astronomers observe today. Cosmic voids also provide valuable opportunities for studying some of the most fundamental questions in cosmology. Because voids contain relatively little matter, gravitational forces are weaker within them. This makes them useful environments for studying the expansion of the universe with fewer complications caused by massive structures. One particularly important topic connected to cosmic voids is the study of dark energy. Dark energy is a mysterious force believed to be responsible for the accelerating expansion of the universe. Since voids are dominated by the expansion of space rather than strong gravitational interactions, they offer an excellent laboratory for studying how dark energy influences the growth of cosmic structures. By examining how voids change size and shape over time, astronomers hope to gain new clues about the nature of dark energy itself. Observational surveys of galaxies have revealed thousands of cosmic voids scattered throughout the observable universe. These surveys use powerful telescopes to measure the positions and distances of millions of galaxies. By mapping these galaxies in 3 dimensions, astronomers can identify the large empty regions between them. One of the most famous examples is the Boötes Void, an enormous region discovered in the early 1980s. This void spans roughly 300 million light-years and contains surprisingly few galaxies compared to surrounding regions of space. When it was first discovered, astronomers were astonished by its immense size and emptiness. Today it remains one of the most dramatic examples of how unevenly matter is distributed across the universe. Despite their emptiness, cosmic voids are not completely devoid of matter. Some contain small dwarf galaxies, thin clouds of gas, and traces of dark matter spread throughout the region. These faint structures can help astronomers understand how galaxies form in environments very different from dense clusters. Studying these rare galaxies provides important insights into the role environment plays in shaping galaxy evolution. In the grand structure of the universe, cosmic voids occupy most of the total volume of space, while galaxies and clusters occupy only a small fraction. Yet together they form the vast cosmic web that defines the architecture of the observable universe. Far from being meaningless empty spaces, these enormous voids reveal how gravity, dark matter, and cosmic expansion work together to shape the largest structures in existence. By studying them, astronomers continue to uncover new clues about how the universe evolved from the nearly uniform state after the Big Bang into the complex cosmic landscape we see today.